ternary ionic compounds. Now in the previous video, right, I did a crisscross method. We did how to write them, yes? Okay, and we did some preliminary naming. But in this video right here, we'll do some quicker crisscross, okay? And we'll go into the naming. Now I'm not gonna be explicit with the crisscross method because that's in the other video. We did that already. But we're gonna use the technique of the crisscross to quickly go through them, get the formulas, and I'm gonna name these guys, okay? Now once again, you always need table E, folks, all right? Now remember, binary compounds, binary ionic compounds, just have a monoatomic positive ion, monoatomic negative ion together, okay? That's binary, two different guys. But in ternary compounds, ternary ionic compounds, you'll see at least 3 or more different elements. And within them, you'll find a polyatomic ion, okay? Definitely. And when you look for polyatomic ions, you look on table E, okay? So always have your reference tables handy, okay? Alrighty, no problem. So here we go. Now, once again, I saw I'm going through quickly, right? Because we did crisscross method already, right? So aluminum is +3, and this guy right here is carbonate, right? Polyatomic ion is CO3 2-, right? So all you have to do is switch the numbers, okay? I keep expressing this over and over and over. Just the numbers, okay? Just the magnitude. So the 2 goes to the aluminum, and the 3 goes to the carbonate. So I'll do it up here really quick, okay? So you have Al +3, right? CO3, -2, no problem. The 2 goes to the aluminum, alrighty? So you're gonna get Al2. Now this 3, right? Remember what we said before in the other video? When the number is larger than 1 going to the polyatomic ion, you gotta put the parentheses around the polyatomic ion. Otherwise, you make no other modifications to the polyatomic ion. Very, very important. So, parentheses CO3, parentheses 3. Okay, so it's Al2, parentheses CO3, parentheses 3. You're done. That's the formula. So what we're gonna do, we're gonna write the formulas for these guys first, okay? And then we're gonna name them. Alrighty. So we got barium, right? Now notice, folks, this charge is 2, that charge is 2, right? So the negative and positive, they cancel each other out. We should be experts with that right now in terms of writing the formulas, right? So when they cancel each other out, all you're gonna be left with is BaCO3, okay? Alrighty. Now NH4 plus is a polyatomic ion, +1 charge, right? The 1 goes to the carbonate, and the 2 from the carbonate goes to the NH4. So we gotta put a parentheses around the NH4, alrighty? NH4 2CO3. Now guys, one more thing. In terms of 1s going across to the other guy, don't show 1s as subscripts, guys, okay? It doesn't make it wrong, but it's like bad forms, like wearing pajamas at school, okay? So make sure you don't show 1s as subscripts. Okay, so aluminum and SCN, okay? SCN is 1, goes to the aluminum, so you simply get Al. Al is a +3 charge, so the 3, just the 3 goes to the SCN. So here we go, bam, SCN, and you get a 3 right there. Alrighty? Alright, Ba, SCN, same thing, but this time there's only 2 going over to the SCN. So it's Ba, alright, the 1 from the SCN goes to the Ba, doesn't really change it or anything. Parentheses, SCN, bam, put a 2 right there, you're done, you move on. NH4 plus is +1, SCN is -1, so it balances each other out, alright, there's no subscripts to be shown. NH4, SCN, and you're done. Okay, so you see the pattern? Nice and simple. Alright, so this guy right here is phosphate at the top right there, and we're combining phosphate with aluminum, right? Now notice, right, aluminum is +3, phosphate is -3. So what happens? You should be experts right now. Those 3s will cancel each other out, right? Okay. Now guys, don't smash these guys together, okay, and just think that they're all gonna be like neutral with no subscripts. You have to respect the charge, guys. If it's the same charge, they cancel each other out. Or if you have like a 2 and a 4, they can reduce each other, all right? But if you have like a 2 and a 3, okay, they don't cancel each other out, so they don't make a compound with no subscripts, so you gotta be careful, all right? No problem. So this guy will give you AlPO4, okay? Because the 3 cancel each other out, leave ones, we don't show the ones, no problem. Okay, if BA and PO4, the 3 from the phosphate goes to the BA, so it's going to be BA3. Now the 2 from the BA goes to the phosphate, so there's parentheses PO4, okay, parentheses 2. Notice PO4 is still PO4. We changed nothing about the polyatomic ion except putting a parentheses around it when needed. Otherwise, don't change it, all right? Okay, and the last formula we're gonna do is NH4 plus with PO4. The 3 goes to the NH4, all right? It's polyatomic ion, so we need a parentheses, all right, 3, and PO4 gets the 1 from the ammonium, okay? Bam, here we go. All right, guys, so we just successfully did our crisscross methods. Now let us name these guys. Now between aluminum and CO3, right, there's some simple rules, but one main simple rule we have to follow, right, is this. Do not change anything about the name of any polyatomic ion. It is what it is, what it is. Whether it's negative polyatomic ion or positive polyatomic ion, leave it as is. They're beautiful. So all you have to do, look on table E, bam, you're done. Whatever name's there, you use that for polyatomic ions. For monoatomic ions, if you have a polyatomic ion with a positive monatomic ion, the positive monatomic ion, you don't change that name either, okay? So that's another nice thing. The only thing you have to modify is if you have like a positive, okay, polyatomic ion with a negative monoatomic ion. So we'll look at it in a second, all right? Like for example, if you have ammonium and sulfur making a compound, right? It'll be ammonium sulfide. That's the only thing you have to change. But otherwise, polyatomic ions, read them off as is off the reference table. Okay, so Al is a positive ion, right? Monoatomic. So that gets aluminum, no change, right? Aluminum, right? Alrighty. CO3, okay, is carbonate. You look at your reference table, you just write carbonate down. Carbonate. Carbonate, right? Now you may be asking, how do I know this is a ternary compound? It has aluminum, it has carbon, it has oxygen, right? It has at least 3 different things in it. So automatically you know somewhere in this formula must be a polyatomic ion. You don't panic, you look on table E, okay? Once again, BaCO3, right? 3 different elements. So I know this is a polyatomic ion somewhere in this guy. I know this is CO3. Don't make up strange names, guys. Don't make up carbon trioxide. You'll get into, it gets bad, all right? So this is gonna be simply what? Ba is barium, positive monoatomic ion, as is. Carbonate, as is, barium carbonate. So you guys see the pattern? All right, what's this guy gonna be right here? This is NH4 with CO3, okay? NH4 is a polyatomic ion, so that's simply ammonium. You don't change the names of polyatomic ions, it's always whether they're positive or negative. And CO3 is carbonate, right? Now, looking at it originally, right, it looks complicated. Oh my goodness, it's complicated, right? But that's a polyatomic ion, that's a polyatomic ion. And if you have 2 polyatomic ions in a formula, those are the easiest guys to name because their names are both as is, right? No problem. Alrighty, aluminum and SCN, okay? So SCN is thiocyanate, right? No problem. Al is aluminum, so you simply write aluminum, all right? Thiocyanate. Bam, and you're done, okay? It's that easy. Barium and thiocyanate. Barium. Thiocyanate, okay? Ammonium, polyatomic ion, thiocyanate. Ammonium, alrighty? Thiocyanate. All right, done. Okay. Alrighty, let's get this row over here. You have Al and PO4. Now, once again, how you recognize a ternary compound? You see that there's Al, there's P, there's O. There's at least 3 different things. Somewhere must be a polyatomic ion in the formula. It's like, puzzle. You look at table E, you match it up. Okay, I see PO4 right there. That's my polyatomic ion. So he gets the name phosphate. Don't make up strange names, all right? So you can say aluminum, phosphate. All right, and you're done. Okay, Ba Monatomic positive ion stays the same. Barium, right? Phosphate. Okay, and this guy right here has 2 polyatomic ions in it. Now you notice there's 1, 2, 3, 4 different things, right? Don't panic, just look on table E, guys, all right? You see the phosphate part right there, the ammonium part right there, you're gonna name it ammonium. Ammonium phosphate. Okay? All righty, and you're done, okay? So that's it. So what I'm gonna do right now, I'm gonna do an example, right, where you have a monoatomic negative ion, okay? No problem, we'll call it a day. Okay, so let's just say, folks, they give you something like NH4+, right? And it's making a compound with sulfur. You look in your reference table, top number, you see that sulfur is -2, right? Okay, and ammonium is +1 from table E, yes? Okay, so what we gotta do? We gotta do crisscross method, right? So the 1 goes to the sulfur, subscript, and the 2 goes to the ammonium. All right, so you're gonna get NH4 parentheses 2. Remember, number coming down, if it's higher than 1, you gotta put 2 parentheses around polyatomic ion. S, okay? How do you name this? You got 1, 2, 3 different things. Somewhere there's a polyatomic ion in the formula. You look on table E, you write down this guy right here, it's ammonium, right? Bam. Now, what the funny thing with doing these problems, after a while, you memorize a lot of these guys. They'll just stick on your fingertips, you remember them, like, oh, that's ammonium, that's this, that's phosphate, that's carbonate, okay, no problem. But always use table E just to make sure you have the right formula and the right charges, all right? Now, this S right here, folks, is a monoatomic negative ion, right? Not from a non-metal, yes? So we have to modify the name, okay? Positive, monoatomic positive ions, we don't modify the name. Polyatomic ions, we don't change the name, right? But for monoatomic negative ions, make a note of that, monoatomic negative ions, you must change the name, just like in the binary compounds. So this will not be sulfur, it will be sulfide, okay? So that's the only modification when you're doing these ternary ionic compound formulas. One last thing, guys. When you're doing a crisscross, right, notice the numbers go from the charge of the other guy to the subscript, charge of the other guy to the subscript. Please don't put numbers after you cross them as exponents. What do I mean? For example, if you have barium, right, it's +2, and you have something like phosphide, right, P-3, right, and you're making a crisscross, don't put B, A, and then put a 3 up here, and then put the P2 and put a 2 up there as an exponent. That will get you no credit, people. You gotta follow the rules. IUPAC Systems, the official body. You gotta follow the naming system properly, okay, guys? So don't put them where you feel like putting them. Put them where they're supposed to be. All right, guys, study hard. Take care.